So I'm going to be finishing up my U-substitution videos right here, and I just have about uh, two or even three more difficult examples, depending on how much time I have by the end of my second one. And these are really just three a little more challenging U-substitution ones, especially if you're learning it for the first time. So let's just give this a shot. So remember before I said that we want U to, where the integral, or sorry, the derivative of it is somewhere in our integral. So, and I also said that it's usually within another function. So I see something in a square root function, so I'm going to say 1 minus x. And so you see if I do that, then I get a negative 1 dx, and that's the same thing as negative dx. And then I can just divide both sides by a negative, and I get negative du equals dx. Again, if I'm going a little fast, watch my previous video on U-substitution where I definitely slow down. I'm just going fast because this is the second part of it. Okay, well, you see here that this dx gets replaced, right? This dx gets replaced with that. This 1 minus x gets replaced with the u. But do you see what's going on? You see that this, this x over here, he's stuck there. He didn't get replaced. And you might be thinking, well, I gotta try a different u now. I gotta let u equal something else. And you can try all you want, but it's not gonna work. So there's a technique to do this though. And it's really pretty logical if you think about it. So again, and I'm gonna write it like this. It's not formal to write it like this, but I'm just gonna show you. Also, let's change the limits of integration as well. So it's just for upper, it's just 1 minus 0. Bottom, it's 1 minus negative 3. Just plugging the upper limit into here and the lower limit into here. So it's just 1, and that's equal to 4. Okay. So again, it's not proper to do this, but I'm just going to show you really quickly. So 4x square root of u. You see that, and then I have a negative out front from this negative du. So the negative can just come out front, and the 1 minus x got replaced with u, and then this dx is negative du, where the negative part is over here and the du is here. So I can only integrate though with respect to one variable, right? And it's really improper to write it like this. Don't write it like this. I'm only just doing it so you see the point. So I have to somehow get that x in terms of u. So what I'm going to do is I'm going to look at this right here. So I said u, and I'll do it in red so you kind of see the point. U equals 1 minus x. Is there a way I can get this x alone and get it in terms of u? And the answer is yeah. So if I subtract a 1 from both sides, and then I divide everything by a negative 1, I get 1 minus u equals x. Basically, just that's a negative 1 plus u, same thing as 1 minus u. So that's, what I did was I now have something that represents x. That's just 1 minus u. So now it's in terms of x, or x is in terms of u, excuse me. So now let's do that. So this is from 4 to 1, negative, and then 1 minus u, and then rad u. Okay, so that's usually an extra step to do. If you make your U-substitution and you see that like a lone variable, it doesn't get absorbed by the du, or doesn't get absorbed by the let u equals blah blah blah, and it's just kind of sitting there. See if you can rewrite it in terms of u, and that's what I did here. I said u equals 1 minus x, and then I solved for x basically, and I said, hey, x is the same thing as 1 minus u, because remember the whole objective of our integrals. We want to, of U-substitution in general, we want to be able to get rid of all of our x's and dx's and replace them with u's, and we do whatever is possible to make that happen, and that's what I did here. So one more thing before we even continue is that you see that this 1 and this 4 are flipped around, right? The bigger ones on the bottom, smaller ones on top. What I like to do is I like to just flip the order and put the negative there. So negative 1 minus u rad u. But you see here I have a negative and another negative, so these are just going to cancel, right? So those will just go away. And then I'll just get the integral from 1 to 4, 1 minus u, and I'm going to write just times u to the 1/2 instead of write u. Remember what I said, it's good to write roots in terms of powers, that's all. Okay, so now I'm going to distribute that. So this is running from 1 to 4, u to the 1/2. So u to the 1/2 minus u to the 3/2. So u to the 1/2 minus u to the 3/2 du. And so now we just take the integral, So taking the integral of this, and again, I encourage you to try these on your own as well, and it feels like I'm going too fast. Watch my older videos on this where where I slow down and go through the process of it, because now I'm kind of streamlining this because I feel like we're all comfortable enough with it. So minus 2/5 u to the 5/2, and then 4 to 1. So get that. Now I'm just going to plug in my upper limit of integration. So 2/3, 4 to the 3/2 minus 2/5, 4 to the 5/2. Okay, and then we do a minus, and then we plug in the lower limit. So 2/3, 1 to the 3/2 minus 2/5, 1 to the 5/2, 1 to the 5/2. And if we do all of this, all these calculations, we're going to get negative 116 over 15. And that's my answer for that one right there. So a little tricky, a little difficult, but definitely nothing we can't handle. So that's really all there is to this one. So again, to recap, I let u equal minus x, and then I saw like, hey, this x didn't get replaced, so then I said, hey, can I rewrite x in terms of u? And the answer was yes. And then once I got all of it in terms of u, it's just same thing we did before. And then again, I saw that the lower limit was bigger, so then I flipped the order and I tossed a negative out front. These negatives canceled, and then I just did what we've always done. And I didn't show step by step for this portion right here because again, that's just simple arithmetic, and I'll just give you the answer so you can check your own work if you want to try this on your own. So it's just negative 116 over 15. Okay, so let's try another example. Let's try, let me clear the board. Okay, so let's try this one right here. Let's try 4 pi, so the integral is 4 pi squared. So from pi squared to 4 pi squared times 1 over rad x times sine rad x dx. Okay, so we have to decide what u has to be. Well, just by looking at this, I kind of want u to be rad x. I see that it's within a sine function, and remember my slight rule of thumb that's not supposed to be taken too seriously is that u is usually what's inside of another function. So that's going to be my first instinct. That's going to be my first candidate. So I'm going to say let u equal rad x. Okay, and we also want the derivative of it to be somewhere in this integral as well, so it'll cancel out nicely. So du equals 1 over 2 rad x dx. So you see here, in my original integral, I have a 1 over x and I have a dx, right? I have a 1 over x and I have a dx. But this 2 is out here, so I need to bring this 2 over to the du, right? Because I need du, some form of du to represent 1 over x dx. So I'm just going to bring this 2 over. I'm just going to bring this 2 over, multiply both sides by 2, and I get 2 du equals 1 over rad x dx. Beautiful. So now, here's what happens. This portion right here, these two guys, right, they get replaced with that. 1 over rad x dx. Again, they're not next to each other here, but this is multiplication, so the order doesn't matter. Like, 5 times 4 times 3, that's the same thing as 3 times 4 times 5, which is also the same thing as 4 times 5 times 3, blah, 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 blah. The order doesn't matter, so this dx could be right here for all I care. But again, so this 1 over rad x and this dx, they get replaced by this du, 2du right here. It's 2du. And then this sine, or sorry, this rad x, right, that gets replaced with u. And then we're working with a definite integral here, so do not forget to change your limits of integration. So the top one, remember you just plug the original upper limit into this right here, whatever your u is. So it's rad 4 pi squared, and that's just 2 pi. And then the bottom one, again, I'm using u sub t for top, u sub b for bottom. Not any proper notation, just my own way of doing it. So square root of pi squared, again, just plugging the lower limit into whatever u is representing. U is representing rad x, so plugging this into that right there. Okay, so square root of pi squared is just pi. Now I can rewrite this integral with my new upper and lower limits of integration. So I'm going to have some from pi to 2 pi, 2, and it's just good notation to bring the constants out front. It just makes it a little nicer and easier to read. So 2 sine u du, right? Because the rad x became u, and then 1 over rad x dx became du, or 2 du. And we changed the upper and lower limits of integration. So let's just take the integral like we've always done. Negative 2 cos u, 2 pi to pi, and I'm going to get negative 2 cosine 2 pi minus a negative 2 cosine of pi. So negative 2 cosine 2 pi, well, that's just simply negative 2 times 1 plus these two negatives will become a plus, so plus 2 times negative 1. And I'm going to get negative 2 plus negative 2. And that's just going to give me a negative 4 as my answer. So pretty clean result. So that's that one, a bit trickier. Definitely something you have to think about a little bit, but nothing too extreme. So let's do one last example for U-substitution. So let's say I had the integral from x, the integral of x over 1 minus x to the fourth, and this is an indefinite integral. So what can I let u be? Well, okay, so number, general rule of thumb, if it's inside of another function maybe, so let's try that, 1 minus x to the fourth, I take the derivative of that, I get negative 4x cubed dx, and you can see here, I don't have an x cubed dx in here, I just have an x dx. I don't have a negative 4 in there, I could bring the negative 4 over here, but I don't have an x cubed dx, that's not going to go away. And when this happens, you see that this doesn't cancel these x's out, you got to try something else. So this is a weird one. What you have to do is you got to be very, very clever about this. It's very tricky. So what I'm going to do here is I'm going to represent x to the fourth as x squared squared. So 1 minus x squared squared. Once you agree that this is the same thing, x squared squared is the same thing as x to the fourth, okay? Just a different way of writing it. Okay, so now what I want to do is I want to say let u equal x squared. Okay, and this looks a little weird. You're probably saying, why not let it equal to 1 minus x squared squared? Because I'd get in the same position as before. So I'm going to let it equal to something else now. And if you're taking your test, this might take a few tries to find out what u should be. So du is equal to 2x dx. And then you see here, I have an x dx here and an x dx here, so I'm on the right track. So I get 1/2 du equals x dx. Okay, so this is looking pretty good. So I get 1/2 and then times 1, well, what was x squared? X squared was u, so 1 minus u squared. Because remember, u only represented x squared, just this little bit in here, but that little bit still got squared, so it's 1 minus u squared, because u only represented x squared. Remember, this was x squared squared, so it's just u squared. And then again, this is actually turns out to be a nice integral, believe it or not. 1 over square root of a 1 minus x squared or u squared. This is going to turn out to be, and again, the constant joins it, 1 half sine inverse u plus c. But then remember the last step. We started with x's in our original function. We started with x's, and I want to get back to x's in my original one. So I'm going to say this is equal to 1 half, well, what was u? U was just x squared, right? U was x squared. So 1 half sine x squared, and then plus c. So 1 half sine inverse x squared plus c is our final answer. So this one's a little tricky. Sometimes you have to manipulate it algebraically first before you do your U-substitution, or do some maybe trigonometric stuff. Again, these can be very tricky if you're not careful, and you really got to be up to speed on your algebra as well as your trigonometry, and so on and so forth. So again, hopefully this helps. U-sub is something that confuses a lot of students at first, and if you don't get it the first time, don't feel bad. Just do as many practice problems as you can. And as always, thank you for watching.